Imagine, in the middle of a dark space, a small blue planet is spinning. Suddenly, from there, a small vehicle rises, heading toward the unknown. It's not just a vehicle, it's a symbol of human dreams, courage, and unstoppable will. NASA, the organization that turned this dream into reality, has carried out countless space missions and experiments up to today. But behind every success were countless obstacles, failures, and relentless technological development. In today's video, we'll see how NASA, starting from 1958 until today, organized this journey of conquering space, what obstacles they faced, and how they continuously kept updating their technology. NASA was established on July 29, 1958, with the signature of U.S. President Dwight D. Eisenhower. The main reason behind it was the Soviet Union's successful launch of the Sputnik 1 satellite, which happened on October 4, 1957. This event kicked off the space race. NASA's first goal was to send humans into space and test how they could work there. The first human mission program was Project Mercury. Between 1961 and 1963, it completed 6 crewed flights. On February 20, 1962, John Glenn became the first American to orbit Earth in the spacecraft called Friendship 7. But this success was not easy. In the beginning, rocket failures, mechanical problems, and human physical limitations were major obstacles. At that time, NASA was in a very early stage of computer technology. They used transistor-based systems, which were far less powerful than today's smartphones. Then came Project Gemini from 1961 to 1966. It had 10 crewed missions. Here they tested spacewalks, rendezvous, and communication between 2 spacecraft. It was the preparation for the Apollo program. At that time, fuel management and oxygen supply problems appeared as obstacles. NASA updated its technology during this period, creating new navigation systems and advanced life support systems. The Apollo program was NASA's biggest dream and greatest challenge. On May 25, 1961, President John F. Kennedy announced that by the end of this decade, America would send humans to the moon and bring them back safely. To achieve this goal, NASA began the Apollo program. The first major disaster came on January 27, 1967. During practice for the Apollo 1 mission, a fire broke out inside the capsule. Commander Virgil Grissom, Edward White, and Roger Chaffee, 3 astronauts, lost their lives. This incident completely stopped NASA in its tracks. Investigations revealed that the pure oxygen environment and faulty wiring were the main causes. NASA then redesigned the entire spacecraft. They introduced fireproof materials, an improved hatch system, and safer electrical wiring. From this obstacle was born NASA's modern safety culture. Then came the era of success. In December 1968, on the Apollo 8 mission, Frank Borman, Jim Lovell, and Bill Anders entered lunar orbit for the first time and saw Earth rising from behind the moon. But the most historic moment came on July 20, 1969. On the Apollo 11 mission, Neil Armstrong and Buzz Aldrin stepped onto the moon's surface. Neil Armstrong then spoke the famous words, "One small step for man, but one giant leap for mankind." That changed the history of Earth. Michael Collins was waiting in the command module at that time. Behind this success were countless technological advancements. NASA built the Saturn V rocket, which was the most powerful rocket in history at that time. They used integrated circuits to make computers smaller and stronger. New software was created for navigation on the lunar surface, but the challenges were not over yet. In the Apollo 13 mission of 1970, after an oxygen tank exploded, Jim Lovell, Jack Swigert, and Fred Hayes had to be brought back safely, and NASA showed incredible improvisation. They used the lunar module as a lifeboat, and together with ground control, turned an impossible mission into success. The Apollo program ended in 1972 with Apollo 17. By then, a total of 12 humans had walked on the moon's surface. This program taught NASA how to solve complex problems in deep space and how to rapidly update technology. After the Apollo program, NASA entered a new era. On May 14, 1973, they launched Skylab, America's first space station. It was built by converting the third stage of a used Saturn V rocket. 3 crew missions spent a total of 171 days there. Scientists conducted important experiments on solar observation, Earth photography, and the effects of long-term human presence in space. But during Skylab's launch, damage occurred to the solar panels and the meteoroid shield, which made temperature control challenging for the crew. NASA solved the problem through ground instructions and manual repairs by the crew. On July 15, 1975, came the Apollo-Soyuz test project. It was the first international human mission, where NASA's Apollo capsule and the Soviet Soyuz spacecraft docked in space. This mission opened the door to cooperation between the two superpowers during the Cold War. Then began the Space Shuttle program. On April 12, 1981, the Columbia Shuttle was launched for the first time. It was the world's first reusable spacecraft. From 1981 to 2011, a total of 135 missions were completed. The shuttles played a vital role in repairing satellites, launching the Hubble Space Telescope, and building the International Space Station. Technologically, they used tile-based heat shields, advanced avionics, and powerful main engines. But this program also faced major obstacles. On January 28, 1986, the Challenger shuttle exploded just 73 seconds after launch. 7 crew members lost their lives, including the first teacher astronaut, Krista McAuliffe. Investigations revealed that the O-ring seals of the solid rocket boosters failed in cold weather. This incident brought serious changes to NASA's culture, giving priority to safety protocols and restructuring the decision-making process. On February 1, 2003, the Columbia shuttle was destroyed during re-entry. A piece of foam insulation struck the wing's heat shield during launch. 7 crew members again lost their lives. These 2 disasters taught NASA that along with complex technology, organizational culture and risk assessment are equally critical. Through the shuttle program, NASA widely updated technology, such as digital fly-by-wire systems, advanced robotics, and long-duration life support systems. After the shuttle program, NASA began a new chapter of international cooperation. On November 20, 1998, with the launch of Russia's Zarya module, construction of the International Space Station, ISS, began. NASA led this project. On November 2, 2000, the first crew, Expedition 1, arrived at the station. Since then, there has been continuous human presence on the ISS, making it the longest-lasting human presence in space in history. On the ISS, NASA and its international partners, such as Russia, Europe, Japan, and Canada, have conducted thousands of experiments in microgravity on biology, physics, astrophysics, and human health. Here they studied the effects of long-term space travel, such as bone loss, muscle weakness, and vision problems. At that time, major obstacles were construction risks, failures of solar arrays, and cooling systems. NASA solved these through the robotic arm Canadarm2 and spacewalks. Technologically, they developed advanced life support systems, recyclable water systems, and high-speed communication networks. At the same time, NASA explored the solar system through robotic missions. In 1997, Mars Pathfinder and the Sojourner rover landed on Mars for the first time. Then came the Spirit and Opportunity rovers in 2004, Curiosity in 2012, and the most advanced Perseverance rover on February 18, 2021. Perseverance landed in Mars's Jezero crater, searching for signs of ancient life, collecting rock samples, and testing the first-ever flight on another planet with the help of the Ingenuity helicopter. The biggest challenges in these missions were distance, delayed communication, about 20 minutes, dust storms, and extreme temperatures. NASA updated technology through autonomous navigation, advanced artificial intelligence, and the Deep Space Network. At the same time, exploration of other asteroids and outer planets continued. In 2005, the Deep Impact mission deliberately struck Comet Tempel 1, and in 2015, New Horizons reached Pluto, sending back its first detailed images. NASA was not limited to human missions alone. They sent powerful observatories to uncover the deep mysteries of space. On April 24, 1990, the Hubble Space Telescope was launched from the Discovery Shuttle. At first, due to a flaw in its main mirror, the images came out blurry. In 1993, during the first servicing mission, shuttle crews installed new corrective optics and rescued it. Later, 4 more servicing missions were carried out. Hubble continues to send countless images of the universe's birth, black holes, exoplanets, and distant galaxies. On December 25, 2021, the James Webb Space Telescope was launched on an Ariane 5 rocket from Kourou Spaceport in French Guiana. James Webb, the most powerful and expensive observatory in human history. It took position at the Sun-Earth Lagrange Point 2, about 1.5 million kilometers away from Earth. Webb's 6.5-meter golden beryllium mirror and advanced infrared instruments are revealing the universe's first light and detailed information about exoplanets with atmospheres. After launch, precisely aligning the mirror segments was a major challenge. NASA solved it through extremely precise engineering. At the same time, NASA expanded commercial partnerships. Since 2014, the Commercial Crew Program began. On May 30, 2020, SpaceX's Crew Dragon capsule carried NASA astronauts Doug Hurley and Bob Behnken to the ISS for the first time. It was the first human launch from American soil since the shuttle's retirement in 2011. Boeing's Starliner also completed test flights. These partnerships helped NASA reduce costs and increase frequency. Now comes the Artemis program, returning to the moon and preparing for Mars. On November 16, 2022, the Artemis 1 mission launched with the Space Launch System SLS rocket and the Orion spacecraft successfully orbiting around the moon. It was the first test of the most powerful rocket of the new generation. In Artemis 2, 4 astronauts will travel around the moon, and in Artemis 3, humans will land on the moon's South Pole region. The main obstacles in these missions were budget limitations, political changes, and risks of advanced technology. NASA is continuously updating advanced cryogenic engines, the Orion heat shield, the Lunar Gateway Station, and AI-based autonomous systems. NASA's missions were not limited to the Moon and Mars. They also deeply explored other planets and smaller bodies of the solar system. The Cassini-Huygens mission, launched in 1997, entered Saturn's orbit in 2004 and sent extraordinary data until 2017. It discovered details about Saturn's rings, its moon Titan, and signs of possible life beneath the ice of Enceladus. On September 15, 2017, Cassini was deliberately destroyed in Saturn's atmosphere to avoid contamination. The biggest challenges of this mission were the long 20-year journey and managing power from the radioisotope thermoelectric generator. Launched in 2016, the Juno mission has been orbiting through Jupiter's intense radiation belts, providing detailed information about the planet's interior, magnetic field, and rotation. In 2018, the OSIRIS-REx mission collected samples from the carbon-rich asteroid Bennu and returned them to Earth in 2023. It was the first American mission to bring back samples from an asteroid. NASA has also been a leader in Earth observation. The Landsat program has been running since 1972, capturing accurate images of Earth's surface changes, deforestation, and climate change. Through missions like Terra, Aqua, and Sentinel-6, Michael Freilich, they monitor sea level rise, global temperatures, and atmospheric gases. These data are invaluable for climate scientists. In recent years, commercial partnerships have expanded further. SpaceX's Crew Dragon regularly carries astronauts to the ISS. In 2024 and 2025, multiple Crew 8 and Crew 9 missions were successfully completed. Boeing's Starliner also completed its Crew flight test in 2024. This commercial model helps NASA reduce costs and conduct missions more frequently. However, challenges still remain. China's rapid progress, budget limitations, supply chain issues, and risks of new technology keep NASA constantly cautious. They are continuously updating ion thrusters, concepts of nuclear propulsion, advanced AI, and robotics. NASA's long journey is not just a story of technology and science. It is a story of human curiosity and the will to cross boundaries. Starting in 1958 with only a few hundred employees, today NASA has become the world's leading space agency, working with thousands of scientists, engineers, and partner organizations. Every failure, whether Apollo 1, Challenger, Columbia, or early rocket launch failures, made NASA stronger and safer. They learned that the success of complex missions depends not only on technology, but also on organizational culture, transparent communication, and risk management. Constant technological updates are NASA's greatest strength. They have advanced from transistors to modern quantum computing and artificial intelligence. Today's missions involve autonomous robots, real-time data analytics, advanced material science, and concepts of nuclear propulsion. Through the Artemis program, they aim to make the Moon a testing ground for future Mars missions. Plans are underway to build permanent lunar bases and the Gateway Station. At the same time, NASA plays a vital role in solving Earth's problems. Climate change monitoring, disaster prediction, and the development of sustainable technologies are integral parts of their mission. Partnerships with the commercial sector, SpaceX, Boeing, Blue Origin, and others are making space more accessible and frequent. So far, NASA's missions have shown humanity that the impossible can be made possible when courage, science, and teamwork come together. Every successful landing, every new image, and every new discovery reminds us we are children of space. In the future, when humans step on Mars, when we reach other star systems, NASA's relentless journey will continue to be an inspiration. Space still holds many mysteries, and NASA, with its experience, courage, and continuous technological progress, is ready to uncover them. Because exploration is the most beautiful expression of our humanity. So that's it for today's video. If you enjoyed the video, like and share it with your loved ones. To always get the latest exciting information first and stay connected with us, follow our social media accounts. The link is given in the profile. We'll see you again in another new video with a new topic. Until then, stay well, stay healthy, and stay with us.